Hi, my name is Mirzel and I'll be presenting the paper Machine Body Language Expressing a Smart Speaker's Activities with Intelligible Physical Motion. This is QUBI, a smart speaker prototype with a vocabulary of expressive physical motions to complement its conversational interaction and make its activities intelligible. The aim of this research was to investigate whether we could design machine mannerisms for smart speakers. Would people understand these physical motions? And what could we learn from how people responded to those motions? We are seeing a big increase in the use of smart speakers in homes, allowing people to access a variety of services hands-free. With the increase of smart speakers in homes, the sense of an omnipresent digital assistant becomes a reality. A family can organize themselves irrespective of where they are located in their home, and they can have access to home automation with voice interaction. And smart speakers can be viewed as context-aware systems, as they attempt to act appropriately to the context. But as pointed out by Bellotti and Edwards, complex sensing systems' behavior may be unpredictable. And instead, the system should reveal to its users what the system knows, how it knows it, and what it does with that information, which is what intelligibility is about. And one thing we observed in prior work is that smart speakers have intelligibility issues too. Bosharan and Beneteau and their respective colleagues have previously observed many instances of a lack of clarity about the smart speaker states in households. We have also observed interactions with an increased number of interconnected devices accessed through smart speakers in homes, which raise infrastructural intelligibility issues. These issues are rooted in the way smart speakers and interconnected devices are unclear about their underlying activities, connectivity, and availability. With this rapid expansion of home automation, smart speakers still provide little to no information about their inner activities, while also having limited expressiveness, making them rely on voice as the primary source of information. Prior work has also pointed out the tension between primary smart speaker users and passive users who are not included nor part of the process of automating homes with smart speakers. Due to the necessity of smartphones, there is a lack of access to smart speakers' activities and interconnected devices availability. So we wanted to investigate how we could imbue the new generation of smart home technologies with such expressiveness or machine mannerisms so that human beings could better understand their intentions. We were inspired by some prominent examples that made us think about how smart speakers could do similar things. This is part of a larger movement in research to look into alternative approaches to clarify what systems are doing. One of those approaches is to make activities and presence of smart devices more clear in the physical space by physical motion. And ripple thermostat is an example of utilizing the physicality of the device to communicate the state of the device. The state that the thermostat is in is expressed through force feedback. Another example is the mechanical ottoman, which uses physical motion in a room to communicate to the user what it is about to do, and with the lid moving up and down to indicate change in its state. So, could physical motion be applied to smart speakers to communicate their behavior? Well, we designed the smart speaker prototype QUBI. It has 4 degrees of freedom and using 9 motors. It has a LED ring to communicate 4 primary states, and it has a flashlight that can point at other smart appliances. We also designed an initial vocabulary of 9 motions, and to give you an idea of what QUBI can do, I'll go through these motions. So QUBI can rise up to indicate that it is ready to attend to the user's request. After some seconds of inactivity, QUBI goes back to the idle state. QUBI nods to confirm a request. It shrugs when it cannot understand a request, and it shakes when it cannot perform a request. It leans forward to indicate that the user should get closer if QUBI could not hear or understand a request. QUBI wiggles to offer 2 alternative interpretations of the user's request if it is unsure. QUBI can point at available smart appliances or when it is about to control a smart appliance. And lastly, QUBI can lean backwards to indicate that it is difficult to hear things due to loud background noise or music. And these are all of QUBI's 9 motions. And what we really wanted to know is if people would understand these motions and how they would respond to a smart speaker with such physical motions. Our study approach was designed around a Wizard of Oz lab study. We recruited 12 participants who each went through 4 scripted scenarios. They were all encouraged to think aloud during the interactions. But before interacting with QUBI, we showed the participants QUBI's 9 motions and asked them to describe the motions. Each session concluded with a semi-structured interview about the participants' experience with QUBI. So we went through each of QUBI's emotions with the participants and asked them to describe the emotions with one word or one sentence. The green color highlights a number of participants who interpreted each motion the way we intended to be interpreted. There are also examples of literal observations such as the shake. The participants expressed during the interview that the motions were much clearer in the context of use. However, the leaning forward and back was still not as clear compared to the other 7 motions. Our findings were grouped into 6 main themes in how participants responded to and interacted with QUBI, but due to time, I'll only go through these first 4. The first one is a video that illustrates mirroring and mimicking.
In a way, I liked his uncertainty in a way when he was shaking and swaying from side to side. Mm-hmm. That's a very human thing to do, or gesture to do. Yes. I was quite surprised that he could do that.
So in this situation, the participant is showing me by mimicking what QUBI did. We also observed other instances of mimicking QUBI's motions, but also mirroring, such as when QUBI nodded, some participants nodded as well. In a similar way, we observed how participants used their body language to supplement voice instructions. Pay attention to the participants' hands.
Hey QUBI, turn off the appliances.
All right, turning off all devices.
As hinted at in the 2 previous findings, anthropomorphism and personality was noticeable. Note that the participant is trying to add carrots to the shopping list.
It's a vegetable in orange called carrot.
Sorry, I am not sure how to help.
It's a plant growing in the earth, quite long, and it's orange.
Finally, in this bit, you will notice some of the other observations overlap when the participant reaffirms one of QUBI's uncertain interpretations of her request to support mutual understanding. She specifically confirms that it's the second choice that QUBI offers. Also notice her hand gesture when she confirms the request.
Hey QUBI, please add carrots to the shopping list.
Okay, I have added captains to your shopping list.
No, not captains. Please add carrots.
Did you mean cannons or did you mean carrots?
I meant carrots, the second, carrots.
Now, these were only some of our many observations for each finding. From our findings, we discussed 3 promising research directions for future research on smart speakers. One direction includes more experiments, explorations, and investigations of other shapes and forms of QUBI with different motions and modalities. QUBI has 3 cubes, but that is only one way of doing it. More paths exist. One example is perhaps a more abstract and organic design like the greeting machine by Anderson-Bachan and colleagues. Another one draws inspiration from Van Oosterhout and colleagues' ripple thermostat, which expands and changes shape. A third form could be similar to QUBI, but with a rather flat and wide form factor. Another direction includes the customization of the machine mannerism of smart speakers. Users could potentially mold and shape their smart speaker's behavior through direct manipulation, in a sense teach the device meaningful motions that are relatable to the users. Anthropomorphism is an example of a robot that memorizes the movements that users teach it through direct manipulation. Our third direction was inspired by human data gestures. So QUBI cannot recognize gestures, but we noticed that our participants use gestures to point at things while talking. And this could be a next step. Design QUBI's ability to recognize people's body language and gesture to support a mutual body language awareness. And so our research has shown how adding physical motion to a smart speaker's form can make its conversational interaction more expressive and make its activities within an IoT ecosystem intelligible. The research suggests that it is possible to derive an initial machine mannerism vocabulary for smart speakers, consisting of a set of expressive physical motions that are readily distinguishable and complement and enrich the existing conversational interaction. This kind of machine etiquette is intended to inspire researchers to think about alternative approaches to designing our interactions with smart technology. For more details, please read the paper. And this concludes the talk. Thank you.